Okay, first, sorry that there's two videos. I'm only able to record 15 minutes, and so that other one was 15 minutes. So the last thing that we were going to cover is example 5 and just finding the rate of change, which you're used to seeing this to find the slope. And now what we're just going to do is it's going to be f of b minus f of a over b minus a. It's the same thing, it's just in function notation now. So let's go ahead and start with this one right here. So we are looking, actually, we'll just go in order so that it's not all over the place. So f of x equals 1 is the function that we are using. And so we are going to look at the interval from -2 to 0. So a would be, I'm going to change colors here. A would be -2 and b would be 0. So if we're following the function over here, we can do b minus a on the bottom. We know what those are. So b is 0 and then minus a, which is -2. And then to find f of a, we need to plug in -2 for x. Well, in this one, it's just a constant. There is no x in there. So we're just looking at 1. And then f of b, same thing. We would plug in f of 0. But again, we just have a constant. So on top, it's just going to be 1 minus 1. So now we have 0. And then 0 minus a -2 would be 0 plus 2. And so there's 0. Okay. And then you'll do the same idea here and here for these boxes. I'm going to switch colors again, and then I'm going to go to the next column and we're going to look at that one. So in this one, we have a is -2 still, and b is 0 still, but now we have a new function that we need to plug in. So if we're looking at f of a, we said is -2, and we're going to be plugging that in here. So we have 1/2 times x, so that's where we're plugging in the -2, and then minus 1. So that would be 1/2 times -2 would be -1, minus 1 would be -2, and then f of b would be f of 0, and we're plugging in that now. So 1/2 times 0 minus 1. Well, anything times 0 is 0, minus 1 would be -1. Okay, so f of a is -2, f of b is -1. So on here, f of b we said is -1, and then minus f of a, which is -2, and then b minus a on the bottom, so 0 minus -2. So this is -1 plus 2, and this is 0 plus 2. So here we have 1/2. And again, you would do the same idea with the bottom two. And I'm going to do one more, and then I'm going to have you pause the video and try the next one. So we have h of x equals x squared. So f of a, I'm going to change a different color because that one's not very bright. I mean, very dark. It's enough for you to see. Okay, f of a, again, we're plugging in -2. So -2 squared, that would be 4. F of b, we would have f of 0. 0 squared is 0. So we have 0 minus 4 over 0 minus a -2. So now we have -4 over a +2. So our slope would be -2 on this interval for that function. Go ahead and try the other 6 boxes. So here's the first column done, and as you can see, we got 0 on all 3 answers. So the average of change stayed the same here, and that's because if we were to graph f of x equals 1, it's a constant. line. The slope is not going up or down, it is just constant straight. Go ahead and finish the next column. Again, here's this column done. And again, you should have gotten 1/2 for everything. So these two columns here so far have had a constant rate of change in all three. So both of them had a constant rate of change. Now we're going to finish the next column and see if we can get another constant rate of change. Okay, so if we finish that one, you see that it is not a constant. So we have -2, 3, 1. And if we think about the function x squared, it's a U shape and it doesn't have a constant. It goes down and then faster at different rates at different times of the graph. So it's okay that we got different answers here. So what's that saying? That this function does not have a constant rate of change. So this one does not have a constant rate of change. And then these two, we got the same answer both times, so those functions do have a constant rate of change. Okay, and that's it for today for 1.1.